All right, Remo has disappeared because Keynote wants to take over both of my screens. So can I get a bit of a verbal confirmation that this is appearing correctly?
It is appearing correctly for me.
Perfect. That is all that matters, Michael. All right, so with the awkward song and dance of the setup out of the way, let's go ahead and talk about sort of the obligatory topic, which is life cycles, like even giving like all of the unprecedents in times into account. I feel like it's still pretty standard that we're going to talk about life cycles, and that's what I want to do today. But before we really get into it, I want to motivate why we're talking about life cycles, because this is a little bit of a different life cycle talk than what you might be aware of. We're going to be talking about assumptions specifically. And as software developers, it's sort of our job to make assumptions about how things work. If we don't make assumptions about like what our product managers want and how the world works, then we won't write a single line of code. We'll just never get anything done. So we have to make some assumptions, and some of them will turn out to be correct and they won't change over time. Others will find out that somebody changed their minds, or we just guessed correctly from the very beginning. And that's fine, and we just address those later on. But the problem comes when you're making false assumptions about the framework and the platform that you're building on top of. Because when this happens, you'll get crashes and bugs that you are blinded into believing aren't possible. And that's because of misunderstandings about how the system is working. And specifically with life cycles, there's a lot of opportunities to make these kind of mistakes. And I work with Michael at Big Nerd Ranch. And if you've heard of us, you're probably aware of our teaching, but we also do consulting on more of a day-to-day basis, which means that we see a lot of different code bases. And I can tell you that a lot more people than you would expect are making a lot of these decisions, even some of the really basic ones. So I'm going to go through basically all of the lifecycle problems that I see people making. And if you're making these, just know that you're in good company. So without further ado, we're going to go ahead and get started. And this really requires us to go all the way back to Activity Recreation 101, and more specifically, your first Android application. Because when you started out working as an Android developer, maybe with some coding like challenge or some side project, you probably started out with something really basic like this. This is just a counter application. If you hit the increment button, then it'll count up. If you hit the decrement, it'll go down. And you spend some time building this out. It runs in an emulator, and it looks pretty good, and you're really happy with yourself. And then you rotate the phone, and something unexpected happens. Because previously, you had some count here. It was 4 in the previous slide. But then after you rotate the phone, that goes away, and you're not really sure why. So you do some Googling, and you go through these steps generally in some order. But the important thing here is that you'll realize what happened was there's something called a configuration change, which happens when the phone goes into landscape. And the way that Android handles that is it destroys and recreates your activity. And it does this to make sure that it fetches the correct resources for the new configuration, in this case, landscape. So if you go down more of the basic path, people will guide you towards on-save instance state. And you'll sort of go through this hassle of you have to put all of this state in a bundle, and it's not really the most pleasant thing to do. And it's kind of a hassle that you just always have to remember. And eventually, you'll start working on some other application that is larger than just a counter, and it'll live in some real world. And in this real world, you're very likely, hopefully if you have a designer at least, for your designer to ask you, well, can we lock the app to portrait? And when your designer says this, you might respond with this, because you might think to yourself, well, activity recreations and orientation changes are a lot of hassle to save the state. So if we only support portrait, then that means that I don't have to think about those. And this is the first false assumption. If we were to call it out, it's that orientation changes are the only reason that your activity restarts. And this is incorrect. We'll see this more in just a little bit, but you don't know about this yet. So you go into your Android manifest, you add these lines of code, and all of a sudden you no longer have to worry about activity recreations caused by orientation changes. And that's fine. And then your QA team says, well, there's this thing, multi-window, where you can have 2 apps side by side. Is the app working for that? and you're not really sure. So what you do is you go ahead and you run the app and you put it into multi-window, and sure enough, the state goes away. So depending on which route you go down, your team might decide, well, let's just not support multi-window. If this is the only other case where this happens, then it's sort of a power user feature and we just don't want to support it. And this is another false assumption, and really just an extension of the first one, that there's a small number of reasons that your activity restarts, and multi-window is just another one of them. This is also wrong, but if you did want to go through with this, you would go into your Android manifest and you would update it with all of these lines of code for your activity. And if you're starting to feel concerned about this, then that's probably a good sign, because there's a lot of suppressions here. And if you had multiple activities, you'd have to have this on every single one of them. So this is generally a code smell that something is up and you're not really considering everything. But again, you might not be thinking about that. And eventually your product manager might come to you and you might just be talking about that new Samsung foldable phone that exists. And somebody will ask you, well, does our app run on that? And you might not be sure, so you'll go ahead, do some Googling, figure out that you can, in fact, save the company $2,000 and download an emulator. So you go ahead and set that up. And sure enough, the app does run on the foldable phone. And then you unfold it and something truly bizarre happens. Because when you do that, the application still works and it didn't lose any state, but it's got these weird black bars around it, and it's also got this message that appears to the user. So what has happened here, if you specifically say that you don't support orientation changes and you don't support multi-window, then foldable phones will put you into this sort of compatibility mode where if you unfold the display, you don't get an activity recreation, but the system won't automatically resize your activity, and you'll end up with these really awkward black bars. But it does also provide the user an option to restart the application and go full screen, which your users are almost certainly going to press. And as soon as they do that, then we're right back to square one. We're resetting the counter and all of our state is lost. So this is a bummer. If you go down a different route, then somebody on Stack Overflow might be guiding you to use this attribute in your Android manifest called config changes. And the documentation specifies that there are some red flags here, but it's really easy to add. So you can go ahead and try it and see what happens. But this is yet another false assumption that really there's any way to prevent your activity from being recreated. And that config changes is one way to do it. So really there's two false assumptions that you're making here. The first one is about how config changes work. And the second one is that you can prevent your activity from restarting at all. We'll come back to this in a minute, but if you wanted to update your Android manifest, you would delete the lines from before, and you would add this config changes line right here, and you would add this orientation, screen size, screen layout, and smallest screen size. And this actually doesn't look that bad. We don't have to suppress any warnings, and this will get us by for the most part. But there's more going on here, and we need to visit in more detail what's actually happening. So here is a mostly comprehensive list of reasons why your activity can restart. So far, we have been focusing on this set, which is configuration changes. And more specifically, everything that we have been talking so far has fallen under one of these two buckets, either orientation or window size. So things like the foldable phone is really just another way of window size sneaking into things. And if you're supporting like multi-window on foldable phones, you're probably also going to be supporting Chrome OS and any other resizable forms, including anything that the platform adds later on. So if you use config changes, you'll handle these two situations, but there's a couple of others that we haven't handled. For example, if a user goes into their language settings and changes the language that the app is going to be displayed in, or if they do something like change the font size if they're using the accessibility options, or on some versions of the operating system, this will even happen if you change the SIM card, then certain other parts of the configuration get changed, and the system will issue a configuration change to your app when the user comes back to it. So we're handling the most common ones, but there are still these other scenarios, and there's more than just these three, where users can change settings that result in your application restarting. And then there's night mode. Night mode is special because language, display factor, and MNC and MCC, those are actually other attributes that you could add to the config changes attribute. It gets one really long line in XML if you were to do that, but you can do it. Night mode is special because you cannot do that. There is not a config changes flag for night mode. This is partially because it lives a little bit with the app-compat library, but the result is if you are supporting night mode, you also need to be supporting configuration changes. This also means that you can get a configuration change if the user is running low on battery, because low battery can also trigger night mode depending on which options the user has enabled. So at this point, someone will probably be telling you to use ViewModel. Either your platform lead or someone on Stack Overflow will be guiding you towards using ViewModel. And if you use ViewModel, this is great news because you're handling all of these other configuration changes, and you will also handle the situation where you call restart yourself. So any of these other situations, if you are using ViewModel and you are able to encapsulate all of your state into your ViewModel, every single programmatic restart and configuration change that you can throw at your activity is being handled, and you don't have to jump through any special hoops, and that's great. But you might be noticing that there's some grayed out stuff on this slide, and you might also publish this to the Play Store and then get some user feedback that looks something like this. So at some point, you might hear that users are saying, well, I came back to the app and I was working on this thing and it's just gone and I'm not seeing it. And there's another set of assumptions that are going on in this scenario. So what has happened here, even if you have all of this state into a ViewModel, that's not necessarily enough on its own. ViewModel singletons and static variables can all be reset under a specific situation. So if you're storing state just in those areas, then that's not a guarantee that it will be persisted through the lifetime of your application. So we also need to focus on a different category of application restarts, which falls under the bucket of process eviction. The main one that we think about is low memory, but there are other scenarios that will trigger this. Android is doing this by design. It's killing your process for various reasons. This is very intentional. But the idea here is that this should be completely transparent to the user. What will happen here is whenever Android determines that it's in a situation where it needs to clear your application for whatever reason, it will completely terminate your process using the sig kill flag. So you don't get a chance to respond to this at all. But your application still appears in the list of recent apps. So the idea here is that you should be able to save all of your state using your saved instance state bundle on save instance state. And you should store all of the information there so that you can restart your application and get into your previous state. The save instance state bundles are kept even if your process is killed. So the idea here is because those are saved, you should be able to take those and get back to where you were. It might just take a little bit longer, and you might have to do a network call or something just to get exactly all the information you had before. Like I said, the main reason that we're talking about this, or the main reason that it comes up really, is something called the Viking killer by a few people at Google and also me, and likely now also you. More formally, this is known as LMKD, which stands for the Low Memory Killer Daemon. Its job is to kill any application that is taking up too much memory in the background, either because the system needs memory or because there's some other memory pressure scenario where it needs to evict your application to reclaim memory. And like I said before, when this happens, your application does still appear in the multitasking list. So it's really important that this is completely transparent to the user and that your application can gracefully respond to this. Another less common and less well-known scenario that triggers process death is actually related to permissions. There isn't a callback to deny permissions, so Android has to get a little bit creative with how it does that. If you revoke a permission, your process can be terminated to make sure that you're not hinging on that preference, on that permission being granted. So if you're in a situation where you check that a permission is granted and then you store that somewhere in a static context, Android is doing this to make sure that you actually are rechecking the permission whenever it gets denied. In practice, though, this behaves the same as the Viking killer. It's just triggered at slightly different times. The other consequence to this is, depending on how you are using permissions in your application, you might actually be making assumptions that because you check for a permission earlier in the flow of your application, that you'll have it later. This isn't true if you are doing something like launching a viewfinder for a camera in a separate activity. That activity can be recreated, and if you don't check for a permission on that activity itself, you will get an exception. So be really careful about this as well. Another thing that I want to talk about that people might be aware of is the force stop button. This has absolutely nothing to do with any of the other process eviction scenarios that I talked about. When you hit the force stop button, it behaves differently, and it actually evicts the entire backstack and saved instance state. So it doesn't appear in the recent apps. And if you relaunch the app, it'll start all the way from the clean slate, and you don't have to worry about surviving this scenario. So the logical question is, if there's not a button on the phone to do this, how do I test it? And there's two options here. There is a library called Venom. I did not write it, but it is on GitHub. It will give you a notification that can terminate your application's process. This can be really useful if you've got QA testers and you want them to be able to do this. Otherwise, if you want to test it yourself in Android Studio, then there is a process that you can do that. You'll run the application in Android Studio. You'll leave the application like not clearing all your activities, but just putting it somewhere else so that your activities are all in the stopped state. You'll then hit the stop button in Android Studio in the Run tab, and then you'll relaunch the app on the device. That'll behave exactly the same as the other scenarios that we've been talking about with process death. So upon hearing this, if you're already using ViewModel, the logical fix for this is to use the saved state library. So what that looks like is in your Android manifest, you now only have one line here, and this is really good. This is going to be some of the only code in this presentation that I actually recommend you use. But then you'll go into your ViewModel. You'll have some methods that look like increment and decrement counter. And then you'll update them so that they have this additional state. So your constructor for your ViewModel will take into this save state handle object, and then you can read and write values into that handle, much like you could with a normal bundle. And this works exactly the same as those bundles, so the same restrictions apply. If you have opinions about ViewModel and you don't want to use it for whatever reason, you can also use the onSave instance state. It will work just fine. You can do whatever you need for the architecture of your application if somebody on your team has stronger opinions about this. With that out of the way, we're now handling everything in our every scenario that our activity could restart. And at this point, you may be bargaining for, well, at least we didn't break a lot of really big assumptions, like at least our application's initialization logic is safe. And I have some bad news about that, because some of your initialization logic might not be executing. So this brings us into the next set of things where not only do we have falsehoods about life cycles after our activity launches, but we also make incorrect assumptions about how our entire application is launched. A lot of us do something like this. We'll have some splash screen activity where we've got some important initialization work that we need to make sure finishes before we start our main activity. The code will look something like this. To the users and on our activity backstack, when you launch the application, you get a splash screen that looks something like this. After a bit of time, it'll finish and it'll launch your main activity. And then the splash screen will be dismissed from the backstack. So what you're left with is you're left with just your main activity. And then the only thing behind that is the launcher. But going back to the process death scenario, when Android restores your process, it only restores the activities that are on the backstack. So if you have important initialization logic that happened in your onCreate for your splash screen activity, that won't execute when your application restarts. So depending on what you're doing here, if you're doing something like prefetching data, that might be okay as long as you can handle the absence of that data. If you were doing something like initializing your dagger graph, which is a very extreme thing to do that I don't see a lot of people doing, but if you were doing something crazy like initializing dagger, you would get a lot of exceptions very instantly as soon as your application gets restored from process death. So these will appear in your crash reporter if you are using them. And if you have something like this where something absolutely should be initialized when your application starts and it isn't for some reason, this might be why. But there's also another reason why you might be running into issues like this. And this is where we have some really bad news to talk about. Suppose you have some initialization logic in your application, like maybe you're setting up Dagger here for your dependency injection, or maybe you're doing some other library initialization. Your application class may not actually ever execute its onCreate method when the user launches your application. And you may not even be aware of this, but you may be seeing this in your crash reporter if you are using one. The specific exception will look something along the lines of application cannot be classed to whatever application class. That's something that you're more likely to see if you are using a dependency injection framework. And if you were to actually check what class your application context extends from, you would see that the exception is valid. It isn't a counter application in this case. So some logical things that you do a sanity check. You go back into your Android manifest, and sure enough, you did actually register the application. But going back a bit, if it's not your context, then whose is it? If you look at this, you'll see that it's actually using the base application class in this really rare scenario. And this is sort of documented, but very hidden. This will actually happen whenever the user's data is being backed up or restored automatically by the device. What happens in this situation is it's really easy for developers to initialize the universe, as the documentation and a few people from Google describe this. So things like the application class and the content providers are not initialized when your application is being backed up. But your process is woken up to make sure that you can actually read data out of this and use any backup logic that you have that lives inside of your application. But the downside here, really the problem here, is when your application is in this state where it is being backed up and isn't initialized, you can actually still launch activities for your application. And this might happen the first time that you launch your application. So if you're seeing reviews where your users are saying that your app crashes and never launches, and if you're seeing this type of exception, it might be because the backup manager is interfering with how your application is working. This is really upsetting news, and unfortunately, there's not very much you can do. The first thing, if you are really inclined to fix this, the first thing that I would recommend is making sure that your users are actually affected by this. They're probably not going to see this if you have allow backup set to false, although different devices may respect this more or less, especially on older versions of Android. And if it's a really uncommon issue and you're not getting review bombed from this, you might not have to do anything. But if this affects a lot of your users, then there's not really a whole lot you can do. This is behavior that's outside of your control, and I don't recommend disabling backup just to avoid this one bug. The most solid example that I've seen somebody doing of working around this is that you can check if the application class is yours. So you can check if you're in this state where the system is backing up just by checking whether or not the application class is an instance of whatever class you defined in the manifest, or if it's the base class. And if you see that it's the base Android application class, then you can just abort early and tell your users, we're setting up, we need to just give us some more time to initialize our application. And you can just finish the activity before it does anything that would normally cause it to crash. This isn't ideal, but it is better than crashing, which is something. And at this point, we've actually accomplished quite a bit. We've talked about a number of reasons that your activity might be incorrectly restarting. We've also actually fixed, most likely, a lot of crashes that you may or may not be aware of. But our product manager is coming to us, and they're really upset that we haven't been working on features recently. So we're going to get back to those. Our designer is likely at this point coming up to us saying that we want to show some details page where we've got a list of items and we want to see more details about some particular thing, whatever is applicable for your domain. In this case, we've got some student where you can see some information for some student. Maybe you're working with like a registrar for a university or something. Either way, you want to see student details. The first option I would recommend if you want to go this route using fragments is to use fragment arguments. I'm sort of stealing this from the Big Nerd Ranch Android Essentials material, but one thing that we strongly recommend is these new instance methods on your fragments that have all of the arguments for the fragment that you need. And then you can also just put them in as a parcelable or something else. If you're using the navigation library, then you have some other fanciness going for you. So you can specify that you have argument types in your navigation graph. And if you're using the compiler plugin, then you get these navigation instructions that accept the arguments for the specific type for all of your navigation operations. If you're not doing one of these two, then double check that you're not losing any state. And make sure that you're testing your app, because there's a very good chance that if you rotate the phone and get recreated after a configuration change, you might be losing this state if you're not doing one of these two. But the real problem with arguments, and with student in particular, is that student might be a really big object. There's already a couple of limitations that people are aware about because the compiler enforces it on us. For example, there's only a limited number of types that we can put inside of a parcelable, but there's also actually a size limitation. So the other assumption here that we're making is, first of all, if we're not doing one of these two things, we might be trying to do something really devious, like we might be using like constructors or just setting properties directly on the fragments. We also might be having problems with other types of data that we're trying to pass along in this bundle that won't work. So here, for example, another slightly worse example of this is to use serializable, because that's a less efficient way of storing this data. Another worse way of doing this is to put a JSON string here, because this is going to be much larger and will very likely exceed these size limits if you have something very complicated happening here. The size limit in particular is 1 megabyte, and this is actually coming from the limitation on bundles themselves. So more specifically, this is coming from the binder transaction limit. This is the amount of data that can leave your application and go somewhere else. So possibly either the activity manager or something else that lives outside of your application. And all of your saved states are eventually making their way to the activity manager, which lives in a different process. The theoretical limit, like I said, is 1 megabyte, but you have much less than this in practice. You also only have one instance of a bundle per activity. So if you have multiple fragments, all of those need to fit in the bundle for that activity. Things like the view hierarchy save state and any other arguments and save state all get combined into that one activity by the internals of Fragment that you normally don't think about. The official recommendation from Google is to keep your bundles under 50 kilobytes, which means that you need to avoid really complicated objects, and please don't use JSON. The other thing about this limit is if you exceed this limit, then one of two things will happen depending on which version of Android you're on. If you are on Android 7 or higher, then you will get a transaction too large exception and your application will crash. If you are pre-Android 7, then whatever operation is happening, so it might be that you're starting a new activity, or it might be that you are saving your instance state. If you exceed this limit and you're pre-7, then whatever operation you're doing will silently fail, which you never wanted to do. So you need to be really aware and be mindful about the data that you are trying to put inside of the save instance state. In practice, it looks something like this. So you have all of these other smaller states getting combined into one bundle. So once you start adding something like a really complicated object, it's not too far-fetched to get really close to that 1,000 or that 1 megabyte limit. And if you're using a JSON string, you can easily exceed this. And the follow-up question is, well, what should I persist? And really, the high-level answer to this is whatever you can define as state. So in the previous example that I had before, we were sending the entire student object to the fragments. You probably don't want to be doing that because that might be a very expensive object and you might need to store it in multiple bundles for the same activity. So what you can do instead is you can store the user or the student ID and then look up the student itself later. Other things that are really good to save are just basically anything that you can't look up again later. So if the user is typing in information and they haven't saved it yet, then you should absolutely be persisting that into your save state. Anything on screen, like if you're doing some A/B testing and you determine that when you show the screen and need to make sure that it's the same one, then you can store information like that inside of the bundle. And generally prefer IDs instead of the actual database objects themselves, like with that student example. You'll also want to use parcelable instead of any human readable serialization form or the serializable Java object. If you're using Kotlin, you can also use the parcelize extension, which is part of the Android extensions Gradle plugin. So you largely don't even have to think about writing these parseable implementations, which is really nice. The next thing that your designer is likely to ask you for is for retry buttons inside of error dialogues, or really just dialogues that have actions inside of them. But retrying is the most common. One option that you'll see in a lot of places is to use an alert dialog. And this will work, except that if there's a configuration change or if your activity restarts for any other reason, this alert dialog will go away, which isn't the best experience. Another thing that you might want to do, you'll definitely want to use dialog fragments, but some people try and get a bit creative and make a generic dialog fragment that they can use with all of their dialogues. And we really want this to work because Lambda expressions make this really nice and they make a really clean API and they make this really reusable. But the problem is there's not a way of really persisting that Lambda expression. So if you're using the advice that I gave before, you might be trying to do something like put parcelable for a Lambda expression, but that's the compiler error because Lambda expressions aren't parcelable. You also wouldn't be able to use them as serializable. If you're using the navigation library, you would also get similar compiler errors depending on which route you go. If you're using Kotlin's Lambda expression syntax, then you'll get an exception because it doesn't know what the Lambda type is. If you actually pull out your own interface and take in an implementation of that, and we're trying to call a method on that, then you would also get a compiler error, or sorry, you get a runtime error because the callback must implement parcelable or serializable, and the compiler knows that the callback isn't one of those things. So with the navigation library, this will all be compiler errors, and you won't be able to do this in either situation. And really the false assumption here is that there is a safe way of using Lambda expressions with fragment arguments. No matter what you're trying to do, if you're trying to pass a Lambda expression into a fragment, there is no way that you can make that work so that it will survive every possible activity recreation scenario. At best, if you were to make this work across configuration changes, you'd be leaking likely a fragment or an activity. Because if you're showing a dialog fragment from an activity and you pass in a Lambda expression, that Lambda expression is probably going to be capturing a reference to the outer activity, and you'll leak the entire activity and possibly its view hierarchy. Alternatively, if you are trying to get these to persist across process diff scenarios, there's no way of stashing whatever state was inside of that Lambda expression because they're at compile time, or really post-compile time, they turn into anonymous inner classes, and there's no way to instantiate them again because their outer reference is permanently destroyed. So instead of trying to use Lambda expressions, there's a couple of other options instead. If you're using ViewModel, then you can share a ViewModel between a dialog fragment and between whatever other component you want to share it between. So for example, if you're showing a dialog from an activity, then you can use activity ViewModels, this by activity ViewModels delegate, to get a reference of the ViewModel that is scoped to the activity. So now the dialog fragment and the activity itself are sharing a ViewModel, and any component that needs to communicate between them can do that. So here, instead of trying to expose and pull out what is happening here, we're now delegating this functionality onto the ViewModel itself. If you don't want to use ViewModel, or if you want to use another, or if you want another way of setting this up, another option is to use a callbacks interface. What you can do here is you can create an interface that defines everything that you need to send back to whatever the caller is. And then you can require that either the activity or the calling fragments implement that interface, and then you can cast that component to the interface, and then you can call those functions on it directly. So that's all great. We'll go ahead and we'll ship that out. But depending on how many users you have, you might also start seeing exceptions that look like this inside of your crash reporter. So we've got all of our features working at this point, and our dialogues are working, and they're not losing any state. And it's not really obvious what is happening here, or why this is an issue. But if we look more closely, what's actually happening here is that the fragment manager is complaining here, if you're seeing this particular crash, because you might be in a situation where you're trying to add or remove fragments while your application is not in the foreground. This is another false assumption where you can just perform fragment transactions whenever, which isn't the case. And to demonstrate why, we need to talk about a fairly common flow, which is that you're doing something like, in this case, you're uploading a photo, and then you'll leave the application to do something else. In this case, let's say that you get a phone call from your mother, and you are a very good son or daughter, and you know that it's in your best interest to take this call. So you go ahead and answer the phone, but whatever you were doing on that other application is still happening. It's just happening in the background. So at this point, if there was an error uploading the photo for whatever reason, and you tried to show a dialogue, then all of a sudden you're trying to perform a fragment transaction while your application is in the stopped state. This is not allowed by default. And the rationale here is whenever you are showing a fragment, that fragment is only guaranteed to be shown if you're showing it in the resumed state. Because if your activity is in the middle of being destroyed, then fragments only get recreated if they are in the saved instance state bundle. The fragment manager itself will try and add them there. So if you're performing a fragment transaction after your state is already saved, then there is no guarantee that that fragment transaction will actually execute. And the default behavior is to disallow this entirely and to crash your application. If you're using the navigation library, this will actually just fail silently. So if you do something like show a dialogue or change screens while your application isn't in the foreground, nothing will happen. You won't get a crash, which is nice, but if you're expecting something to change, then that information won't appear whatsoever. Depending on what you're doing, this might be OK, but realistically, once you're in this situation, there's no way of guaranteeing that your application will save its state ever again. It could be that your application comes back into the foreground, in which case it doesn't matter that you missed out on that one save state from having your fragments. Or it could be that the system terminates or really evicts your process from memory. And if the user comes back to it, then there's no way for that dialogue to appear. If you're not using the navigation library, or if you want a dialogue to appear without these limitations and to show it and not really care about that edge case with process death, then you can do something like this. What's happening here is this is an extension function that I've just made, which is show allowing state loss. And the idea here is that it will immediately show a dialog fragment. And if the activity goes, or if you are calling this while the activity is not in the foreground, the dialog will still appear. But if the activity gets recreated before the dialog has a chance to show up for the first time, then it'll just never appear. There's not really anything you can do to get better at this, and it's probably going to work well enough, but it won't handle every single edge case, which isn't the best, but it's about as close as you can get. And at this point, you're probably thinking, this is a lot of information that we've gone over in about 38 minutes, and I have many things that I need to be fixing right now. And really, I want to say two things, first of all. The first one is, again, don't panic if you are making these mistakes, because you are in good company and many other Android developers are making these mistakes. But if you're asking for advice on how to fix your problems, then the answer boils down into the really traditional "it depends," because you have to do the right thing for your application. And you might also be making a false assumption that you have to fix every single one of these problems, and that might not be the case. So as a counter argument to a lot of this, you may not need to do anything depending on what type of application you are working on. For example, if you're not publishing your application to something like the Google Play Store, or if you're using it in a really limited environment, it doesn't really matter if you're not handling every single one of these edge cases. Likewise, if you have an application that you haven't updated since the gingerbread days, you probably don't need to go back and fix it. I don't think that people are going to care about it. Similarly, if you're showing off something in a sample app or like a toy application, and it doesn't matter whether or not it supports process death, as in you're not building a sample to show off how to support process death and activity recreations, it probably doesn't matter that you're not supporting these. Likewise, if you're running on controlled hardware, like if you were doing something like a kiosk or working on something that runs on like a Samsung smart refrigerator or something, it probably doesn't matter that you don't handle configuration changes. For example, if your refrigerator suddenly ends up in landscape orientation, you're probably having a very big problem, and configuration changes are probably the least of your concerns at that point. The other situation is if you're working on a game engine like Unity, for example, then you may not want to handle the activity recreation by letting your activity get destroyed and recreated, because this can introduce a lot of latency into your application. So if you're doing something like this, it does make sense to use config changes. And if you look in the documentation, that's one of the examples that they give of one of the use cases where using config changes makes sense. But for everyone else, we're probably going to have to do something. And the general rule of thumb is if you plan on publishing to the Google Play Store and you are not a video game, you probably need to be thinking about these. And really, the way that you do that is to embrace activity and fragment recreations. Don't try and fight the system. Google basically every year with every new version of Android does something that adds more features and hinges on your activity being able to be recreated and support these features. So the really easy way of doing this is to use ViewModel and save state or saved instance state bundles that'll get you basically all of the situations that you need. And to avoid config changes, that Android:config changes tag in your Android manifest, along with the other workarounds that we saw that don't really work. I will also add some exceptions here, one of which is WebView, because WebView does not support having its state saved. It did up until about Lollipop or so, but it turned out that if you weren't restoring that state, then that would leak disk space, which is a bummer. So on newer versions of Android, there isn't a way of saving the state for WebView. So if you have something like an activity that is full screen and only displays a WebView, it might make sense for it to use the config changes tag. Similarly, if you're doing something with surface view, so likely something with camera, video, or video games, it probably makes sense to use config changes just so that you don't have any jarring recreations and you don't have to do anything to temporarily pause playback or anything. The other advice is to tolerate process eviction. So make sure that your application will work gracefully when your process has been terminated. Make sure that if your splash screen is skipped, you can work with that. You can cope with that state. Make sure that anything that you're doing to preload your application there can also happen lazily. If you're relying on your static variables or any singletons to be in a given state because you have gotten to some activity or some part of some flow, don't make that assumption. Because it might be that if your activity or your process gets recreated and gets completely destroyed and evicted from memory, anything you have set up might not be in the same state. So make sure you are persisting any information and recovering it either to a database or using the saved instance state bundle for anything that you cannot recover. Also, just in general, if possible, prefer lazy loading instead of mandatory prefetching on startup. So if you're doing something like preloading some data for your application, presumably you would be able to do that lazily, and that would probably be a better experience for your users just in general. The last piece of advice that I have is to test your app in all of these situations. So do things like trigger configuration changes. And if you are required to support portrait in your application, then change the display size, change the language. Run through and use the Venom application or the Venom library and the Android Studio steps to see what happens in process death scenarios. Also, there's a setting in the debug options and the developer options on your phone called Don't Keep Activities. Don't rely on this. You can use this to test, but it's not representative of real-world behavior. Android doesn't destroy any activities that are on the backstack. And it also doesn't destroy activities when your process dies. It destroys the process. So be mindful of these scenarios, but also keep in mind that they might be false positives. And above all else, the only thing that really matters and the key takeaway for really a lot of these kinds of talks is to do the things that are right for your users and to fix the problems that affect your application. Thank you so much for tuning in. I have been Andrew Bailey. You can find more information about this at andrewbailey.dev/falsehoods. And we'll also turn it over to Q&A in just a second.